So in this final video on the trig content that we're covering this year, we're just going to have a look at putting into practice these three new trig functions. The textbook starts the chapter by saying you need to be able to simplify expressions, prove identities, and solve equations involving these three new functions. So actually this function is a really useful reminder and a bit of revision of those previous three skills that we covered earlier in the year. So let's just dive straight in. There's nothing really new to learn here. We just need to apply our old skills. So example 6 says simplify sine theta, cot theta, sec theta. So all we're going to do is remind ourselves that cot theta is the same as 1 over tan theta, and that sec theta is the same as 1 over cos theta. Again, as a reminder, we've got this third letter rule to help you remember which way around they go. And that means that sine theta, cot theta, sec theta is actually the same as sine theta times by 1 over tan theta times by 1 over cos theta. And we've got one other thing we can say. Tan theta is sine theta over cos theta. So the reciprocal of that means we have sine theta and then cos theta over sine theta and 1 over cos theta. And you can now see that the sine thetas cancel and the cos thetas cancel, and actually this is just worth exactly 1. Sine theta, cot theta, sec theta is equal to 1. There's nothing complicated here. We just need to plug in and apply all of those rules that we have. The second example, a little more involved. So now I have sine theta cos theta multiplied by sec theta plus cosec theta. So we'll start it the same way. We'll get rid of the sec and the cosec and rewrite them with the normal trig functions. So we have sine theta cos theta, and then in brackets 1 over cos theta plus 1 over sine theta. General principle here: fractions are unhelpful most of the time. They're certainly not simple, and adding of two fractions also not terribly helpful, but we can combine them if we rewrite these with a common denominator. So if I multiply this one by sine theta on top and bottom, and this one by cosine theta on top and bottom, then what I get is still sine theta cos theta, but now I'm going to have sine theta over sine theta cos theta plus cos theta over sine theta cos theta. So I can combine them into a single fraction. The denominator is sine theta cos theta and the numerator is sine theta plus cos theta. And now you can see that this denominator cancels out with outside of the brackets. So what we're left with is just sine theta plus cos theta, and we're finished. Simplify is usually not too bad. The goal is always to rewrite in familiar terms and then get rid of fractions and tidy up and eliminate terms wherever you can. Example 7 is a prove question dealing with identities. So if you remember when we looked at these, we have a left-hand side and a right-hand side, and we always leave one of them alone. We ignore one of them and we only manipulate the other. In this case, I'm definitely going to leave alone the right-hand side cos cubed theta, because it's much simpler. So I want to take the complicated looking side, the left-hand side, and tidy it up until it's simple and therefore hopefully the same. So we're going to begin with cot theta cosec theta over sec squared theta plus cosec squared theta. And the first thing I can do is I can just rewrite all of these as their standard trig functions. We're aiming for cos cubed, so I don't want any of these reciprocal functions at all. So cot theta is actually cos theta over sine theta, and cosec theta is actually 1 over sine theta, and in the denominator sec squared is actually 1 over cos squared theta, and cosec squared is 1 over sine squared theta. Now, initially that doesn't look better. In fact, it's quite a mess. But we can do a bit more tidying up work here. So again, I've got in the denominator, I've got two fractions which I can just add together by finding a common denominator, and the numerator tidies up quite quickly. So let's just tidy the numerator first, because that ends up being cos theta over sine squared theta, and then on the bottom we've got all of this mess, 1 over cos squared theta plus 1 over sine squared theta. Now to join these two together, I need to multiply by cos squared on one and by sine squared on the other to get a common denominator. So what we're going to end up doing is this is going to still have cos theta over sine squared theta in the numerator, but in the denominator we're going to end up with sine squared plus cos squared all over sine squared multiplied by cos squared. Okay, I've times one of them by sine squared top and bottom, and the other one by cos squared top and bottom. And before we tidy up another notch by getting rid of some of these embedded fractions, we just need to notice something. Right here we have what is hopefully a very familiar identity. Sine squared plus cos squared in fact equals 1. So what we've got now is cos theta over sine squared theta over 1 over sine squared theta cos squared theta. And now, to clear this mess up and to tidy it up, if I multiply the numerator and denominator by sine squared cos squared, so if I times by sine squared cos squared top and bottom, then what I'm going to get is a much tidier expression without these embedded fractions. So cos theta divided by sine squared theta and then multiplied by sine squared theta cos squared theta. The sine squareds are going to cancel out, and I'm just going to get cos cubed theta in the numerator. And then the denominator, I've got 1 over sine squared cos squared multiplied by sine squared cos squared. They cancel, I just get 1. So what we end up with is just cos cubed of theta. Okay, and you can see this is exactly the same thing as our right hand side from the beginning. Now it's worth noting that the textbook separates entirely the numerator and denominator and tidies the numerator up and then tidies the denominator up and then recombines them. That is also absolutely fine to do. You just need to be really clear with what you have and what you're tidying up. If you're going to pull them apart, label one as numerator and one as denominator, or write a little sentence saying, I'm doing this now, just to make it incredibly clear what you're doing and where it's all come from. My preference is to keep it in one, but as you can see, it can get it can get big and messy if you do it that way. Part B then says, hence explain why. Well, hence means use the first part, and hopefully you can see that this is our left hand side from before. So what we're being asked to actually say is, why does cos cubed theta equals 8 have no solutions? Well, in order to solve this, I'd need to cube root this, and the cube root would give us cos theta equals 2, and that is impossible. The reason it's impossible is because cos theta can only lie between -1 and 1, because those are the maximum and minimum values it can take. I would flesh that out with a bit more sentence. That is in the textbook with kind of a bit more detail, but the intuition is fairly clear there. Because I know that left hand side is actually cos cubed theta, I can just deal with this as cos cubed theta equals 8, and that's not hard to show why it doesn't work.